What is network topology? Network topology refers to the layout or structure of how devices, nodes, like computers, servers, and switches are connected in a network. It's basically the blueprint of your network, how everything talks to everything else. There are two main types of topology: physical topology, how devices are actually connected, cables, switches, routers, etc. Logical topology, how data flows within the network, regardless of the physical layout. Bus topology is one of the simplest and most straightforward network configurations. In this setup, all devices, such as computers, printers, and servers, are connected to a single central cable known as the bus, or backbone. This central cable acts as the main communication line, allowing data to be transmitted between devices. When a device sends data, the signal travels along the bus and is received by all other devices on the network. However, only the device with the matching address processes the data, the rest disregard it. To prevent signal reflection and potential data interference, terminators are placed at both ends of the bus. While bus topology is cost-effective and easy to implement, especially for small networks, it has limitations. The entire network can be disrupted if the main cable fails, and as more devices are added, the likelihood of data collisions increases, leading to reduced performance. Scenario: small office network. Consider a small accounting firm with 5 computers and a shared printer. To establish a simple and economical network, they opt for a bus topology. A single coaxial cable runs through the office, connecting all devices. Each computer and the printer tap into this central cable using connectors. Terminators are installed at both ends of the cable to ensure signal integrity. When an employee sends a document to the printer, the data travels along the bus. All devices receive the signal, but only the printer recognizes and processes the print job. This setup is efficient for the firm's current needs. However, if the firm expands and adds more devices, they might experience network slowdowns and increased data collisions, indicating the need for a more robust network topology. Ring topology is a network configuration where each device, or node, is connected to exactly 2 other devices, forming a circular data path. This setup allows data to travel in a unidirectional or bidirectional manner around the ring, passing through each node until it reaches its destination. In a unidirectional ring, data moves in a single direction, while in a bidirectional ring, data can flow in both directions, providing redundancy and improved fault tolerance. YouTube. One of the key advantages of ring topology is its orderly data transmission. Each device has equal access to the network, reducing the chances of data collisions. This structure can handle high data loads efficiently, as each node has dedicated time slots to transmit data. Additionally, ring topology does not require a central hub, which can reduce hardware costs. Lenovo. However, ring topology also has its disadvantages. If a single node or connection fails in a unidirectional ring, it can disrupt the entire network. Adding or removing devices can be challenging, as it may require temporarily shutting down the network. Moreover, as data must pass through each node between the source and destination, the network can experience increased latency with a higher number of devices. Lenovo. Scenario: small business network. Consider a small graphic design firm with 5 workstations that need to share large files and collaborate in real time. To ensure equal access and efficient data transmission, they implement a ring topology. Each workstation is connected to 2 others, forming a closed loop. When a designer sends a file, it travels through each connected workstation until it reaches the intended recipient. This setup ensures that all devices have equal opportunity to communicate, minimizing data collisions and maintaining consistent network performance. In summary, ring topology offers a structured and efficient method for data transmission, making it suitable for networks where equal access and orderly communication are essential. However, considerations regarding scalability and fault tolerance are crucial when deciding if this topology fits the specific needs of a network. Star topology is a widely used network configuration where each device, such as computers, printers, or servers, connects individually to a central hub or switch. This central device acts as the communication conduit, managing and directing data traffic between the connected devices. In this setup, when a device sends data, it transmits the information to the central hub, which then forwards it to the intended recipient device. This centralized approach simplifies network management and troubleshooting, as each device has a dedicated connection to the hub, reducing the chances of data collisions. Advantages of star topology: easy to manage and troubleshoot. Since each device connects to the central hub independently, Identifying and isolating faults becomes straightforward. Scalability. Adding or removing devices is simple and doesn't disrupt the rest of the network. Enhanced performance. Dedicated connections to the hub minimize data collisions, ensuring efficient data transmission. Robustness. A failure in one cable or device doesn't affect the rest of the network. Disadvantages of star topology. Central point of failure. If the central hub fails, the entire network becomes inoperable. Higher installation costs. Requires more cabling and hardware, like hubs or switches, compared to some other topologies. Limited by hub capacity. The number of devices that can be connected is constrained by the hub's port availability. Real-world scenario. Office network. Consider a small business office with 10 employees, each with their own computer, and shared resources like printers and a file server. Implementing a star topology, each computer and shared device connects directly to a central switch. This configuration ensures that if one computer experiences issues, it doesn't impact the connectivity of others. Moreover, adding a new employee's computer is as simple as connecting it to the switch, making network expansion straightforward. In summary, star topology offers a reliable and manageable network structure, especially suited for environments where ease of maintenance and scalability are priorities. Mesh topology is a network configuration where each device, or node, is interconnected with multiple other nodes, forming a web-like structure. This design ensures that data can travel through various paths, enhancing the network's reliability and fault tolerance. NordVPN. Characteristics of mesh topology. Multiple connections. Each node connects directly to several other nodes, allowing for multiple pathways for data transmission. Shiksha. Redundancy. The presence of multiple paths means that if one connection fails, data can be rerouted through another path, ensuring continuous network operation. NetMaker +3. Lenovo +3. NordVPN +3. Decentralization. There is no central hub. Each node plays an equal role in data transmission, reducing the risk of a single point of failure. Advantages. High reliability. The network can continue to function even if multiple connections fail, making it highly fault-tolerant. Wikipedia +4. Lenovo +4. Wikipedia +4. Efficient data transmission. Data can take the shortest or least congested path to its destination, optimizing network performance. NordVPN. Scalability. New nodes can be added without disrupting the network, allowing for easy expansion. Disadvantages. Complex setup. Establishing a mesh network requires extensive planning and configuration, as each node must be connected to multiple others. High cost. The need for numerous connections and potential hardware increases the overall cost compared to simpler topologies. Maintenance challenges. Troubleshooting and maintaining a mesh network can be more complicated due to its intricate structure. Real-world scenario. Emergency response communication. In disaster-stricken areas where traditional communication infrastructure is compromised, emergency response teams can deploy a mesh network to establish reliable communication. Each team member's device connects to others, forming a resilient network that allows for continuous data exchange. If one device fails or moves out of range, the network self-heals by rerouting data through alternative paths, ensuring uninterrupted communication during critical operations. Lenovo. In summary, mesh topology offers a robust and flexible network structure suitable for environments where reliability and redundancy are paramount. While it comes with higher costs and complexity, its advantages make it ideal for specific applications like emergency response, military operations, and large-scale wireless. Understanding network topologies is fundamental for designing efficient and reliable networks. Each topology has its unique advantages and disadvantages, and the choice depends on factors like the size of the network, budget, and desired performance. By selecting the appropriate topology, network administrators can ensure optimal data flow and connectivity.